This is the introduction to the normal distribution curve and variance. This first slide you don't need to write down. I just wanted to give you a little heads up on what is a normal distribution curve in case you wanted to go a little more in depth if you're doing your internal assessment and you want to do some studying of the normal distribution curve. We are not going to get into it in our class. But think about if you were to take a test and your teacher says, I'm going to grade you on a bell curve. What happens is you have this middle of this curve is the average of the grades in the class. And that would be right here. And then you have some percentages to the right and left that are the 68%, 95%, and 99%. Again, you can study up a little bit more on your own on the bell curve or the normal distribution curve. This just kind of goes through some of the reasons why we study the normal distribution curve. If you were to collect data on heights or weights or reading abilities, IQ scores, they are approximated by using the normal distribution. So again, you don't need to write any of this down. How it says here is here's your mean. 50% of your data will be in the bottom half, 50% will be in the top half. And then there's some deviations from that. And what we're going to focus more on in our videos in this lesson is standard deviation. How much does it deviate from the normal distribution? All right, so the first thing I do want you to write down is go ahead and write down this word variance. What variance is the average of the squared differences from the mean. And then you don't need to write down the rest. We will go through it together. I just want to kind of talk you through it. What we're going to do first is we're going to find the mean. Remember, the mean is just average. Add up all the numbers and divide by what the total is. And then what you're going to do is you're going to subtract each number from the mean and then square it. Then you're going to find the average of those squared differences. So I'm just talking you through it again. You don't need to write anything down but the definition. Here is what the formula looks like. If you remember from Algebra 2, sigma notation. Sigma looks like this. It's a Greek letter. It represents sum. So this formula looks a little bit scary, but it's not bad, okay? And we have a formula for variance for an entire population and a formula for a sample. And they look very similar. The only difference is this little notation right here with the n or the n minus 1. So you'll see both ways. All right. So here's an example. You don't need to write this down. You and your friends have just measured the heights of your dogs. The heights of the dogs are shown here. 600 millimeters, 470 millimeters, 170 millimeters, 430 millimeters, and 300 millimeters. And what you do is you add those values up, so you get 1970 millimeters, and you're divided by how many dogs you have. You have 5 dogs, and you get 394. So what we just found is the mean. Then we want to calculate the difference from those means. So this green bar is your mean. And we want to find out what the difference between each of these are. So we have 206 is the difference between the first dog, 76 from the next dog, negative 224 from the next dog, and so on and so on. So those are the differences from the mean. Then we're going to go ahead and square them. So remember the first dog was a difference of 206, so we're going to square it. The next dog, and so on. And what we do is we total that up and divide by 5. And what we get is this value right here, 21,704, and that's called the variance. Now what we're going to do next, and that's more the important piece, is we're going to find out what is the standard deviation. How much does it deviate from the mean? So it's pretty easy. All you do to find the standard deviation is you square root the variance. And what it says is you have 147 millimeters from the mean. That's how much it deviates. Okay, So remember when we talked about, again, you don't need to write this down, there is the population is divided by n, and if you have a sample, the only difference is n minus 1. All right,